Okay, Chapter 9 is Assessment, Appraisal, Research. This is often one of those chapters that people get really nervous about because they think, I don't like math. But one of the things that's really important for you to understand is that your research class and appraisal class that you're going to have in the grad program is not designed for you to go out and do major research applications. They are designed for you to understand appraisals and also understand what research is and how to read it, the comprehension of research itself. So why assess mental health in the first place? Mental health practitioners often want to know if their treatment plans are effective. If you have a client and you're working with them, you want to evaluate that treatment plan on a regular basis and make sure that there is momentum forward, change, or success happening. Otherwise, you could treat someone for years and never even know if your treatment plan is effective if you don't test for efficacy. Second reason, evaluation of new research. When new treatment models come out, new evidence-based programs, you want to be able to, one, read the research and see if it's even generalizable toward the population that you serve, or if it's valid research in the first place. You'll be able to pick it apart and be able to look at it in a way that you know whether or not it's good research. And three, sometimes we just want to know for the sake of knowing, just to gain more knowledge. We see something going on, we want to study it and try to get to the bottom root of it or the experience of what is happening. So understanding and exploring. That's why we assess in mental health. Testing, assessment, appraisal, surveys, they're all synonyms of each other. Basically, what we're saying here is that when you give someone something that studies them and assigns them a score, you take that score and it gives you a representation of that characteristic or behavior or symptom that you can compare to all the other scores of that same test. So if we're comparing a score of a characteristic or behavior, what we're comparing it actually to is all those other scores that have already been obtained. That way we kind of know where somebody lies in what would be considered mild, moderate, severe. Next is when we do a test score, we also often have to remember that test scores can vary. So what we're looking at here is a formula that says the observed score, true score, plus standard error of measurement. Now, basically what that means is that depending on your mood, depending on if it's a good day or bad day, if you had sleep, something happened on the way, your mood, your daily activities can make your scores vary. So let's take something like the ACT. So let's say that you scored 120 on the ACT. Well, if you scored 120 on the ACT, let's just say that the standard error of measurement is 2. Okay? So that means your true score, so this is your observed score, this is what you actually got that day. Standard error of measurement is 2. That means your true score is anywhere between 118 and 122. That's all that it means, that your true score can vary, but it'll stay within this range. So there's formulas that they've done to get these numbers. Basically is the range that if you took it 200 times, it should stay within that range. And that's what true score means. Okay, the next is reliability. When we talk about reliability and validity in assessments, you want to first recognize that the terminology often used in research contradicts your understanding of the English language. So you need to take the terms as they are meant for research and not get them confused. So reliability means that it is consistent, repeatable. It does the same thing every time. You get the same results every time. Where validity means that it does what it's supposed to do. So this one is consistent, And this one is it does what its purpose was. Okay? So you can repeat consistently, do over and over again, get the same results. This one, it does what it's supposed to do. Now I'm going to try to make this as non-complicated as I can. Okay. We have Pluto and we have PJ Masks. Okay. Now, think of it this way. Every morning, Pluto gets in his car. Every single morning he comes out of his door, gets in his car, and it never, ever starts. Then he gets out of his car and goes back in. Every morning, Pluto gets out of his house, walks to his car, attempts to start it. It never, ever starts every single morning. Every single morning, PJ Masks comes out of his house, goes and sits in his car, starts it, and goes on to work. PJ Masks comes out of his house, gets in his car, starts the car, goes to work every single morning. Now, reliability. Which of these are consistent that they do the repetitive pattern every single time? I hope you said both. They are both reliable because they are both consistent and their behaviors or what they did was repetitive every single time. With me so far? Repetitive, both. Consistent, both. Validity. Did both of these, or which of these, did what they were supposed to do? Yes, PJ Masks. Did what he's supposed to do. The car started. That's what the car is supposed to do. So, know this because in any kind of test that you're going to take, you're going to nab this question in the future. Can something be reliable and not be valid? So, can something be consistent and not do what it's supposed to do? Yes. I can give you an algebra quiz at this test and you can fail it every single time. That's still reliable because you did the same behavior every single time. Can something be valid and not be reliable? Can it do what it's supposed to do and not be consistent? No. Know that. Something can be reliable without being valid, but if it's valid, it has to be reliable. That is something you want to burn into your brain. Okay, so let's talk about the different types of reliability here. We've got test and retest. Just exactly like it sounds. If you consistently take tests over and over and over again, you're going to have a range of scores that are going to be consistent. Okay, internal reliability means that it is consistent. The whole assessment or appraisal is consistent. So, for example, if you made an exam and you had separate the odd and even numbers, then if somebody took one side of the test and took the other side, their score should be around the same thing. So that would say that the test overall has got good reliability in their scores. So if you took all the odd and then you come back and took all the even questions, your test scores should still range around the same thing. And that means it would have good internal reliability. Iterator reliability means that other people have observed and agree with the results of the assessment. So something that has good iterator reliability might be the ideal of having a form that was measuring behaviors of a child in a school setting and then having other individuals also observe that child and see if they agree with the results of your assessment. That would be an example of iterator reliability. When it comes to validity and assessment, we have a couple terms you want to go over. And if you're following along in your textbook, we're on page 215. Content validity. Remember, validity says it measures what it's supposed to measure. So content validity is, does this assessment have the information to actually study to actually assess what we're looking for? So does it have the content in it that we need? Another thing about content validity is the spread of information. So like if we were going to take an exam at the end of this class, you wouldn't have that exam just focus on chapters 12 and 13. You would have a variety of questions from 1 to 13. So the table specification, if you look in your book, gives you a graph and it shows like how there's specific questions for each section and for each category. And it ranges from 3 to 5 questions across the board. And that's what table specification is to make sure that you're covering that broad content area and not just focusing on one thing. Criterion related has 2 separate things. It's concurrent and predictive. So concurrent means that if we were to make up a Lindsay Wilson depressive scale, so if we were going to do a depressive scale, if someone took our depressive scale, then they should concurrently also score around the same range on like the Beck depression inventory if we have good validity in our assessment. So somebody that scores a certain level on one assessment, if it's good validity, should also score around the same range in another one. Predictive provides you with the ability to predict, use math and equations to predict something that can happen. For example, they use the GRE score to predict how well you will do in grad school. They use your ACT or SAT score to predict your GPA your first year of college. Those are predictive criterion related type of validity assessments. And then the last one is construct. Construct is about more of a characteristic. So if you take a characteristic like depression, you can't measure depression like you do your blood pressure. There is a device that comes, boom, I'm measuring your blood pressure, and we know that's the result of your blood pressure. The characteristic of depression, however, doesn't have something where we can just go and measure it and provide us with a yes or no if somebody has depression. So it is under the type of thing like a construct. So depression, love, those are constructs. And so when you're looking at construct validity, then you have to look at that assessment as if, does it cover all of the construct? So just like if you're asking about eating on a depression score, it doesn't say have you lost a lot of weight? It'll say, have you lost a lot of weight or have you gained a lot of weight? Because we know with depression, it can go different ways for different people. So does the assessment cover all the constructs that make up that characteristic? So if you was to think about depression, you might talk about the increase or decrease in appetite, increase or decrease in weight, increase or decrease in sleep, lack of pleasure, not showering, something that impacts your daily function. You get the point. So you can't have just a couple of those constructs on there. It has to cover the whole gamut, and that's what they're looking for construct validity. Okay, so then we go to standardizations. So standardization is talking about when things have these reliability and validity factors, then they fall within a group norm. And basically what we're talking about here is we're talking about the bell curve. So you have a couple of different ones. We're going to go like this on this side, and we're going to go like this on this side, and then we're going to do the big one in the middle so that we can go over it. Okay, so when we're talking about standardization and research and appraisal, we're talking about a normed bell curve. So your ACTs, your GREs, all those fall onto this bell curve, okay? And in the middle of your bell curve is your X-bar, your mean. You may also see it represented as a mu, which is a funky M that I can't really draw. So anyway, and it is a number line, right? Whoops, don't know how to count. And it is a number line. Okay, so this is a mirror image. So in the idea of standardized testing, 50% of the scores are here, 50% of the scores are here, which means people fall within this area. So the majority of people fall 68% exact. 68% of your scores, 68% of people on a normed test are going to fall in this range. Okay? Now, what is important about that is that you need to understand enough about the bell curve to be able to explain when somebody falls in or out of the norm range what that actually means. All assessments are not normed. You have skewed assessments. You have a negative and a positive skew. And basically what that means is that your scores have shifted to one side or the other. Okay, so you're going to get into this more in class, so I'm not going to go over it too much. But these are not normed bell curves. These are for non-standard tests. Obviously, what you want to understand about it is if your average on your number line shifts from one side to the other, if this was a test you were taking in class right now, you would want a negative skew because you would want more on the positive side of the scores. And I know, again, the negative, that's called a negative skew. It's one of those things you just got to figure out how you're going to learn it. A lot of people say, I learn it by where the tail is. The tail's on the negative, the tail's on the positive. Whatever you got to do to learn it. You just got to know it that way. So anyway, so you have your mean right here in the middle. You have the majority of the people's scores right here. And that takes you down to types of standardized representation like your IQ test. What do you need to know about these type of things? This is probably the most important one to know as far as memory. So these number lines are your standard deviations. So if your standard deviation is 15 with a mean of 100, standard deviation of 15 with a mean of 100, then here is your mean. So you can write 100 right here, and then for every standard deviation, you add or subtract depending on what side of the number line you are on. Of all the ones to know, you need to know this one. So it's the only one I'm going to actually write up here. But that is 1 plus 15 is 115. Plus 15 more is 130. Plus, okay, I'm going to go up to there. Backwards, we got 85, 70, 60, 55. What does this mean? It's standardized, which means if you took the IQ of everybody on the planet, 68% of the people would fall between 85 and 115. Which is why most of these people never take an IQ test, because we kind of can tell that they're pretty normal. But when people appear low functioning or extremely high functioning, they often get tested, right? So if you get an assessment of somebody and he has an IQ score, you need to at least be able to look at that score and know if they fall above or below the norm. That's probably one of the most important things about getting types of information reports from people. So you're not going to be probably the one that actually does the IQ score, but you will get results from IQ and achievement that are provided by you by people that tested individuals. And so you need of all of them to know that one because it tests their IQ. Intelligent tests measure the examinee's ability to think abstractly and use verbal, numerical, and abstract symbols. That's on page 216 if you're following along in your text. So that's for your IQ. Okay. The next one is achievements. Achievement tests often provide us the ability to find out if there's a reading disorder or math disorder. Even though somebody's IQ might be within the norm, they might actually score below in a specific achievement test, and that allows us to recognize learning disabilities. Aptitude tests are often used for criteria to see how well someone does in specific areas in their abilities. Aptitude tests predict what people can learn. So that's why they use them for the ACT, SAT. Those are aptitude, GRE, LSAT, MCAT. Those are also aptitude tests. Then the next one is personality. Personality test provides you with the ability to assess certain traits, states, types, and your own self-concept. And these are on page 220 if you want to look more into those. And then you have neuropsychological test. Again, one of the important things is our ability to understand the test, read the test, and also know when something needs to be more advancedly studied. So when you look at neuropsychological tests, we might do a mini mental status exam or a mental status exam. We might do a Bender visual motor gestalt or word association test. What we're looking for is issues with the mental status exam or the Bender to look for neurological deficits. We are assessing for a deficit to know if there's more information needed. And that takes us to the last section in the appraisal, which is the ethics. The important parts about ethics and appraisals is that you have to know certain things. Now, this starts on page 222. It is extremely important to know that if you select something, you need to know about it. It's your responsibility as a person providing an assessment to somebody to be knowledgeable at it, to know how to administer it, how to interpret it, how to report it back. Do you know whether or not this is assessment is designed for the population that you're giving it to? Was it generalized for that or normed for that population? Is it got validity and reliability? Have you looked it up in Test and Prints or the Mental Measurement Yearbook to see what type of normed or validity it has? A lot of our tests are designed for white males. A lot of our tests have been studied and tested upon college-age students because they're an easy population to test for. And so it's really important for you to know the background of all the tests that you administer. You also need to know if there's any bias in the test for the population that you might be giving it to. And you are responsible for the administration of it being effective and consistent. Standardized tests, they do them a certain way, and you have to keep with that. You have to maintain that criteria. You have to make sure that your tests are kept confidential. You have to also make sure that they are secure. And you also are responsible for your ability to interpret it and be able to report it back. So you have to write it up, but you have to be able to explain what that means to the person that took it in a way that they can understand it. Okay, and that wraps up the ethics on the appraisal section. Then we're going to go into the research on 224. And it starts off with what the scientific method is. And in the scientific method, in order to do something a scientifically method, it has to be done the exact same way every time. Why? Because we want to be able to do it again. And so we have to write it and do it in a way that somebody could follow along like cooking a cake. You have the directions there. So on the scientific method, the first thing you want to do is develop a research question. What is it you're wanting to know? And then with everything that you do know, you're going to develop a hypothesis, an educated guess about what you think is going to happen. And then you're going to do a plan on how do I figure this out and get these answers, follow through with the plan. Then you're going to analyze the data that you collected, and then you're going to develop a conclusion from that. In doing a scientific research, one of the things you've got to think about in that plan is sampling. Okay, that brings us back to sampling. Got some stuff up here on the board to kind of review with you on this one. The first one is sampling is random sampling. So let's say that we were going to do a study with 100% of our grad student population. And if we were going to do a study with our 100% of our grad student population and we wanted to do 10%, that means we would select 100 students. So we could just randomly just select 100 students, send out flyers and say the first 100 people sign up. That is random selection. First 100 people sign up. However, sometimes when we do that, we're still not getting a very good sample of our population. So there could be specific things that could cause our study to vary in its results, such as an example I'm going to use here is age. So it could be multiple different characteristics that people find different, but we're going to use a stratified sample because we want to know how the grad students studying the habits are by age, not just in general 10%. So if we were to take that same 10% and obtain 100 participants, and this is just me playing with some numbers here, it's absolutely not accurate, but let's say that 45% of our 100% of our grad student population was 25 to 35, 25% was 36 to 45, 25% was 46 to 55, and only 5% was 56 to 65. So if we took that information, that would give us 45 people in this age range, 25 here, 25 here, and 5 here. So I just used numbers. It was really easy to do the math with. But that would be a stratified sample. That would give us a correct population percentage for the group that we were trying to represent. And then our third way of getting a sample is random assignment. Now, random assignment to me is kind of one of those cool things. So if we took this idea here and was still going to select 100 people from these populations, then so we took all the people here in the 45%, let's say we numbered them all, and we had let's say we had 450 people, just to make the math simple. So everybody in here was numbered from 001 to 450, because we have 450 participants. So let's pretend that we gave everybody in this population 0001 to 450 was their number. Now, the reason that they have 3 digits is because there's 3 digits in the biggest number. So if you were doing 1,000, if you were doing the whole 1,000, then the first person number would be 0001, because you have to have the same amount of placeholders. Now, luckily, we have the ability to have computers generate this kind of information for us now, but I want you to understand what a random assignment actually is. So when we say something is randomly assigned, then that means if you put everybody with these 3-digit placeholders, then you would go through what is called a random assignment table, and you would look 0001. So this should be actually somebody that would be our first participant. Whoever's number was 111 would be our first participant. Then we would go to 643. We don't have anybody with that because we only went to 450. Then we would go to 631, 875. There we go. Here's number 2. So this is number 1. 061 would be number 2. That would be our number 2 participant. We're only going to get 45 people out of here. So once you get to that number of 45 people, then you just stop. So 376, that would be number 3. 742, we don't have it. 632, we don't have it. 075, that would be our 4th person. 100 would be our 5th person. 212 would be our 6th person. 159 would be our 7th person. 179 would be our 8th. 176 would be our 9th. We don't have this person. 564 we don't have. 788 we don't have. 705, 431 would be our 10th person. And you would just keep going like that. You can Google a table of random numbers and just kind of see, like, you can get pages. You can get big, gigantic ones. You can get really small ones. But this is how you would randomly pick and get your 45 people. Like I said, there's computer designs to do that for you now, but I want you to understand it. Basically what it's saying, out of those 450 people that you only need 45 of, this gives everybody an equal chance of being selected, because you have no way of knowing who's going to be selected once you give them the numbers. Okay. And then that takes us down to internal and external validity and reliability. Internal validity. Basically what that's saying how well can this study, when you get it done, how well can it actually be interpreted? That's the internal part. How well can it actually be interpreted? The external part is not only can you interpret it, but how much can you generalize it to the population? So if you did a study on female inmates, you can't make that generalizable to the female population at large. So that's what you're looking at for the external validity, is how well can it be generalizable. And then the internal and external reliability. Okay, so the internal reliability is talking about this plan. How well did that plan, how well did it stay consistent within its own study? And the external reliability is how well can we repeat it? Can we recreate it and be consistent with our results over and over again, right? Okay, and then the last section here is operational definition. Operational definition is the idea that when you use specific terms in a paper, that the reader needs to know how that term is specifically used. So if you think about something such as aggression, so if your term that you want to operationally define is aggression, now think about the fact that would we all agree on what aggression means? No. Me as a middle child with an older and younger brother, I'm sure that I view aggression differently than someone that maybe was an only child. So when we use aggression or specific terms in a research paper, we have to operationally define them. So we would say that aggression is, for example, hitting, biting, slapping. So let's say that these are the three things that we term aggression as. It doesn't matter how you define it, but it has to be defined. And all that means is that within this paper, within this specific research paper, when I say the word aggression, I'm only talking about hitting, biting, or slapping. And you just operationally define it so that everybody understands when a term's used, it's been operationally defined as what it means within that paper. And it's not misinterpreted. Okay, and then that takes us down to research designs. So one of the things you're going to learn in your research class is there's a lot of different research designs out there. We're going to start off with a longitudinal study. Basically, all the longitudinal study means that it's a study that's done across time. So if you were doing a study about twins raised in two different places with two different parents, you might study them for 20, 30 years. That would be a longitudinal study. A cross-sectional study is the type of study that you might do where you're getting a snapshot, but the people that are in the study are at different parts in the population. So let's say that you're doing a cross-study section of high school students' experience, but you've got people that are in their freshman year, sophomore year, junior year, and senior year. And so you're going to cut that across the same time frame, but they're in different parts. And so freshmen might have a different experience than seniors, for example. Okay, so direct observation. So that's when the researcher is doing the observing. You can do that in a naturalistic setting. You might sit in the back of a room and observe a student and how they behave in a classroom setting. And that would be a naturalistic observation. You can also do observations like in a lab setting. Participant observer would be the type of where you were observing as part of the population itself. You see these documentaries where somebody might go to an island and learn a tribe's way of hunting and being, and that would be a participant observer type of study. You also need to be careful about when someone knows they're being observed about issues like the Hawthorne effect, where because somebody knows they're being observed, they act differently. And then we have survey methods. There's a couple different types of survey methods. The first one it talks about is correlational. So two of the most common types of surveys are correlation and experimental. Correlation studies a relationship. Experimental is cause and effect. Okay, so these are very important to remember. So you want to make sure that you understand that a correlational study just shows that there's a relationship. Experimental talks about cause and effect. The reason that these things are really important to understand is because you could say, if you don't recognize that it's talking about a relationship, you could say that in Chicago, when the heat rises in the summer, then also some other variable that increases is car theft. Okay? Now, we can say that these two things have a relationship. As the summer heat increases, then the amount of car theft increases. And that shows that there's a correlation, there's a relationship between the two. What you want to know is that you don't want to use terms like cause and effect in a correlational study. You want to talk about there's a relationship there, because then you would say that summer causes car theft. Because you could also say that ice cream sales goes up. So if ice cream sales increases when car theft increases, then does ice cream cause people to steal cars? No. We're saying that there's a relationship. There's a correlation between these. The correlation is probably more due to the summer, right? But it doesn't cause it. Where experimental is absolutely cause and effect. So if you take this medication, it decreases your blood pressure. That's a cause and effect. Okay, and then some different ways that we do these experiments. Okay, within subject designs, and basically there's a lot of different styles of within subject designs, but basically what it's saying is if you have a group of people, you study the group, observe, you study the group 1 and group 2, both that have the treatment, and the group that has no treatment, which is the placebo. So within subject, you're going to have at least 2 groups. One is a placebo group, one is an experimental group. And that is what within subject is, that you study both groups. This is the type of study that you use with a quantitative study. Other types of studies that are often used in mental health are a qualitative study, and that's the one where you develop specific questions and you study more of someone's experience. A qualitative design where you're studying words more than you are measurements on an assessment. Okay, the next one is meta-analysis. Meta-analysis is basically the ability to use previous research and literature reviews to analyze information in a statistical way. And you'll learn more about that as you will statistical analysis and research that uses SPSS programs that specifically uses statistics to obtain information. You'll get more of that in your research class. And last but not least, we go to ethics. Some of the key points that you want to realize with ethics and research is that we have special protected populations such as minors, prisoners, geriatric population. You need to get approval of an IRB, which is an internal review board, and they provide the ability to overlook your research plan to make sure you're not hurting someone, and that you are being ethical in your research and in your plan of how you're gathering information and protecting those that you're studying. Is that when someone is involved in a research, they have to be given an informed consent that provides them all the risks that they may encounter and how to contact, and that they can voluntarily quit the research study at any time, as well as all of your information, the good, bad, and the ugly of it, has to be reported. Okay, and so I think that wraps up chapter 9.